Hello and welcome. So in this video we are deploying a cryptocurrency trading bot in GCP. Advantage of doing that would be operating system doesn't need to be online to execute trades. Please watch this video beforehand, linked in the video description. I will use the code from this video and point out changes I made both to improve the bot and to be able to deploy it in GCP. There are some prerequisites for this video. First of all, as just said, you should watch the previous video. Secondly, I assume you already set up your Linux virtual machine and installed Anaconda on it. I covered all of that in my GCP playlist. I made some changes to the previous script which we will go through before deploying. In a nutshell, that is, we are using the Websocket library instead of the Binance Socket Manager. Also, instead of a SQL database, we are using CSVs to store prices. Furthermore, to improve our buying price, we are using a buy limit order. Regarding the cloud deployment, we are still using a two-script approach. First one is running as a background process in the virtual machine. That means you can exit the shell and it will still run. The second script is running as a cron job, which is also running in the background and doesn't need an open connection to the virtual machine. Important disclaimer, cryptocurrency and specific automated trading is bearing a huge amount of risk and may result in a total loss of your invested capital. Cryptocurrencies are not regulated and the Python and Binance API wrapper is not official. Even more important disclaimer, don't blindly follow my instructions. I'm providing you ideas and show you example trades. You need to do your own research, assess and manage the risk based on your own risk profile. Do not execute code you don't understand 100%. Losses are part of trading. Be aware of the risk you want to take. Don't see these videos as a way to make money. These bots are not end-to-end products. There's a lot of improvement potential. Just see it as a project. Alright, so what you're seeing here on the left-hand side is just the code from the previous video. On the right hand side you see the amended code which we will use in the virtual machine. So let's take a look at some changes. While we were using a SQL database here, I'm just storing the data into a CSV file. Also, all those data manipulations are done within the stream. Right? So no worries, we will go through that step by step in some seconds, but just for the main differences. While we were doing the data manipulations here and provide all available symbols to the multiplex socket, we are doing it slightly different here by using another stream. We're just using the mini ticker stream, which is streaming live prices for a 24-hour window. So it will be updated every 1000 milliseconds and you're just getting the most recent price as the close price here and also the price 24 hours ago, which we won't need, but this is quite handy as our stream, right? And these are basically the main changes here, right? So let's understand how this stream is working. So by the way, this path we will only need for the virtual machine because I'm storing the CSV file in an additional directory which we will create in some minutes. Okay, so this is the mini ticker stream, which is just streaming prices for all available symbols. So let's just take an example here so we can get rid of the left hand side actually. Make it a bit larger here. So this is executed, right? Yeah. So let's take a look at what we are getting. Yeah, let's just do it like so. So I'm just letting that run for 1 second. And now let's print out the message. And as you see here, we are just getting a stream for all the symbols here, BNB, ETH, BTC, USDT, and then getting some information, right? Open is the price 24 hours ago, and close is the most recent price. All right, and this is containing all available symbols here, right? And so what is done here is it's just a translation. So message is a string type, while when we are transforming that with JSON loads, we are getting a dictionary which we can work in Python. So next, we are just filtering out those symbols. So for example, this one here, BNB ETH. So we just want to have symbols which are in relation to the US dollar tether or US dollar. So we are just using a list comprehension here. So we are iterating over this message and just check if this symbol S ends with USDT. And with that, we are getting a filtered dictionary, or rather list, which is containing only the symbols which are in relation to the US dollar tether. All right. And next, we are just, so let's do that on the global level, that you understand what each step is about. So symbol, if I'm printing out symbol here, as you see, I'm only getting BTC USDT, ETH USDT, BNB USDT, and so on, right? And next, we are just storing that to a data frame. So let's actually do that here. And this is just filtering out for the information we need. E is the timestamp, S is the symbol, and C is the close price. So this is the real-time price of the particular asset. All right. So this is looking like that. Okay. So we have a timestamp, the symbol, and the most recent price. Now we are doing some amendments that this is readable. So this is a Unix timestamp, right? And we want to have it like an actual date. So this is what this thing is doing. And frame C is just converting this string formatted column here into a floating value. Right? So this will look like that here. Okay? And now I'm just looping over all those symbols and store them in a CSV file which is named after the symbol, and within this CSV file I'm just storing the timestamp and the close price. So I'm generating, for this tick, I'm generating 83 CSV files with the name of the asset. Okay, and this is what this loop is doing. So for row in range length of this frame we just created, then I'm creating data by just iterating. First iteration would be this row, BTC USDT. Second iteration would be this row, third this row, and so on. So this is what this loop is doing. And afterwards, I'm just filtering for the timestamp and the close price and store that to a CSV file. Provide the path which we will need for our virtual machine, and then just take the symbol as the CSV name, and I'm indexing for 0 here to just get the string value out of BTC USDT. So I'm quickly showing you what I'm talking about. So if I'm indexing for S here, I'm getting a series here if I'm taking values, and if I'm indexing that, I'm just getting the string value. All right. Okay, so this is creating all for every single symbol. This is creating a CSV file. So this is just telling that for every new tick or every new data floating in, we just want to append it to the previous CSV file. Also, we are setting the header to false here. Yeah, and this is just running the Websocket. All right. So, and that's already it for the first script. Okay, so next we are deploying the first script. As you see, I already connected to my Linux virtual machine on GCP. Again, I've explained all of that in my GCP playlist. So first of all, we have to create a directory where we are storing all those CSVs in. So we can do that using make directory and then just give it a name. I'm using CSVs here. And with that, we have created a directory CSVs. All right. Next, we are creating a Python script, and I'm using the Nano text editor for that. and let's just name it Tradingstream.py. And here I'm just copy pasting the code I just showed you, right, with the WebSocket stream. Now we are exiting that, save it, press enter. Now it is not enough to run the trade stream like so, because whenever you are disconnecting from this instance, this stream will stop, or this script will stop in general, right? So we have to do 2 steps to avoid this disconnection when we are disconnecting from this instance. And that is making this Python file an executable and then run a no-hub task. So no-hub is for no hang-up, which is just running the task in the background when this is being disconnected, right? So with that, your script will also run when you're not in this shell here. So first of all, we are creating an executable by using chmod +x and then the name of the script, Tradingstream.py. And now we're using no-hub, Python, Tradingstream, and with that, we are creating a process which is running even though you are disconnecting from this instance. Okay, so let's actually test out the trade stream. But first of all, I'm showing you when we are now changing to the CSVs and take a look at the files. So this is just the Linux command for show me all files in a certain directory. Then you will see that there are already a lot of CSV files here within this directory, right? Now, let's actually test out if we are getting proper data when reading in these CSV files. So let me quickly pull my home path here. And now I'm just starting raw Python here. Import pandas and read CSV. Provide the path, CSVs, and then let's just check for Bitcoin. And as you see, now we are getting the price of Bitcoin since I started the stream, right? Roughly one minute ago. Okay, and when I'm executing this command again, I should get more recent prices, right? Otherwise, something is wrong. And as you see now, we have 87 rows instead of 66. And if I'm executing that again, I have 94 rows. And this row is always including the most recent price, right? So works fine. But now let's do a kind of stress test. What happens when I disconnect to this instance? Will it still work? Well, let's find out. Reconnect again. And now just start Python again, import pandas. CSVs, Bitcoin, and we have more rows than before. So is it still updating? Yes, it is. So works like a charm, right? All right, so let's continue with the second script, that is the actual trading script. So no worries, I'm showing you the full code in some seconds. I just want to make a quick comparison between the code from the previous video and the new. So in the previous video, we were using SQL database, and we were getting the symbols by just requesting all tables within our database, and the tables had the symbol names, and with that we could get all symbols on Binance. Here we are doing it slightly different. We are just listing using the OS library from Python, we're just listing all the CSV files in our CSV directory in our virtual machine. What's also different here when filtering the data for the last n minutes, so last 2 minutes, last 3 minutes, last 5 minutes, we're using a SQL query for that. Now we are just manipulating the CSV file here, right? So we will go through the code in some seconds in more detail. Return calculation stays the exact same, with the exception that the function has another name here, and we have another column name for the price, but everything else stays the same. And calculating the buying quantity, I'm deviating from my approach because my approach was unnecessarily complicated, and some of you provided better approaches, so thank you very much for that. One from Andreas Schulz was, at least in my opinion, very good, so I've just taken that. Then we are using, instead of a market order, we are using a buy limit order here. And the buy price is slightly different typecasted because we have another dictionary when taking your order limit buy or buy limit order here. Last but not least, this is the trade stream after we've bought the asset, implementing a stop loss and a target profit mechanism. Here we are using the Websocket library again, but let's take a closer look at the script itself. So again, we are listing the files in the directory to get the relevant symbols. Then we are reading in, for a particular symbol, we are reading in the CSV file, change the column names. So this is the timestamp and this is the price column. Then we are transforming the timestamp to a date timestamp. So unfortunately, when writing dates to a CSV file and reading them in again, they are stored as object or string values. So we have to do a date typecast here again. Then we are calculating the price series from now back to the time we want to look back, right? 2 minutes, 3 minutes, 5 minutes, 10 minutes, whatsoever. And then we're just filtering for that and return this data frame. So return calculation, I'm not explaining again. We're just looping over all symbols and then calculate the cumulative returns. And with that, we are determining the top coin on the whole Binance platform. Then the buying logic. So we have an investment amount. Then we're pulling some information to calculate the buying quantity. And as just said, the buy quantity, I'm using Andreas Schulz's approach here. Thank you very much for sharing that. It's way better than my approach. Right, and with that we have a buying quantity, and now we're just checking if we have enough funds on our or in our USDT balance. So it should be above 200, or rather above investment amount would be better here. And then we are placing a limit buy order, providing the top coin, then the buy quantity, and we are setting the price to, oh, this is wrong. This must be price, right? So yeah, with that, I just want to avoid price jumps, right? With the market order, when we have the top coin and then just buy in for the market, it can be that we have a very bad entry, right? So with that, I just want to avoid that. You can also set that to below the price, right? Also a possibility. As always, a lot of amendment or improvement potential here. Okay, in the end, the buy price is transformed from the order dictionary, which is created when placing an order. And this stream is from then on, when we have bought an asset, streaming price data for this bought asset. So we are providing the top coin and apply a lower function because the top coin is looking something like that, and we have to get it in not capital letters here. Then we're pulling the trade stream, and this is quite similar to what I did before. So I'm transforming the message to a Python dictionary, screen for the price, check if it's below 98% of my buy price. So this is my stop loss mechanism at 2%, or, and this is my target profit, if the asset was rising by 2.5%. So these are just example parameters, right? You have to figure out if they make sense. There are certainly better ways to determine these parameters. Anyhow, when a selling order has been placed, then we directly want to close the Websocket stream here, right? All right, so let's deploy the second script. Before that, we want to make sure that the trade stream is still running. And by the way, you should always delete the CSVs after some time, so you can implement that in the code. I just didn't do that. But yeah, you should get rid of those files frequently, right? Otherwise, your storage in the virtual machine will blow up after probably some days. So we can do that by just what was the command again? This one, right? Yeah, this one. Okay, so this is just removing all relevant files. And you see we already have new files because the trade stream is still running. But anyhow, let's make sure it's actually running. So import panels, pd read csv. Come on. Bitcoin. And as you see, we are getting the most recent price here. Yeah, exactly the same. Okay, so trade stream is still running. Perfect. Now let's implement the second script. So first of all, we have to actually create that. So trading script, we can just call that. And here again, we are just copy pasting what I just showed you. Return calculation. Buy quantity calculation and the stream when the asset is built. So that's it. Press exit, press yes, press OK. And for this trading script, we are creating a cron job. So cron tab -e. And therefore, we are just executing it every minute. You can also execute that every 5 minutes. That's your personal preference here. So every minute, and then I have to get the path of the Python interpreter. I have to quickly exit that again. Which Python? Okay. So this is the interpreter path which we need for creating this cron job. So we have the path here. Then we are just using tradingscript.py and we want to log what's actually happening here. So this is optional. This is just writing down what is happening when executing the cron job. Okay, that should be fine. So let's execute that and save that and switch to Binance. And there it is. We have placed an order. Let's take a look at that. Drap USDT. And there is the selling order. So this was quite a nice trade. So we reached the target profit. And actually we can disconnect from the instance, right? Okay, so let's take a look at some trades. So bot is still running. As you just saw, we got a selling order here. And we triggered the stop loss with the last trade. But let's take a look at the trades before. So let's go until the first one we traded. That was DREP. Good trade, good trade, good trade. And this was a bad trade, or rather just a stop loss trigger here. So as I already said in the community post yesterday, the problem with this bot is that exploding wins are not captured. And actually those coins are partly rising by 5 or 10% sometimes, right? So I used the bot to buy assets, but manually sold them and achieved way better results. So regarding the exit, there is certainly a lot of improvement potential. But anyhow, I thank you very much for watching. I hope this was interesting for you. I hope this could somehow add value for you. And yeah, let me know what you think in the comments below. And I thank you very much for watching. And I'm looking forward to seeing the upcoming videos. Bye bye.